Okay, so let's talk about the second type of improper integral. So the second type happens when the function is not continuous inside that interval. But we are considering a particular type of discontinuous function. Okay, so type A. So you are evaluating a to b fx dx. Now see, this type of improper integral looks very innocent, like usually you will see it like 0 to 1 and some function, and then if you are not paying attention, you might ignore the fact that it is an improper integral. You have to be very, very careful. Okay, so you are evaluating just a simple looking integral that we always evaluate, a definite integral, but if you see something like this, so what happens is f is continuous, let's say inside a to b, so everywhere in the interval except at this lower limit. And what happening at the lower limit, f has a it's called an infinite discontinuity, an infinite discontinuity at x equals a. And what does that really means is that the line, if you draw the vertical line through x equals a, it is an asymptote. So the function is approaching to infinity or negative infinity when it's approaching to a. Okay, so let's see if I can show you. This looks something like this. Okay, let's say here is my x equals a. And you are going up to b. Okay, and let's say the function looks like something like this. And you are evaluating from a to b. So do you see what's happening, right? Again, it seems like the area might be infinite because this the graph will never touch this line, so it will keep on going. It's an asymptote. And so we are trying to evaluate this area, this entire area, right? And that area might easily become infinity. Sometimes it will, sometimes it won't, depending on the function. So again, how do we evaluate it? See, because it's going to infinity, we cannot just directly plug in a in that antiderivative and use the fundamental theorem. Same exact reason, okay? Because it might become infinity. You cannot just directly plug in. You have to use a limiting definition again. So what do? The point, the limit that is causing the trouble, what we're going to do is we're going to replace that with something, let's say a t. Okay, and in this case, the t has to lie in between a and b, right? And then we just evaluate this area from t to b, but then we slowly move this t, go towards a. That's the limit. So we'll move t a little bit farther to the left and then farther to the left, and we will keep finding these areas, right? And then ultimately, we'll be able to find the entire area if we do the limit as t approaches to a. Okay, so the definition to evaluate this improper integral is instead of a to b, you evaluate from t to b, fx dx, and then take the limit as t is approaching a, but look, t is approaching a only from one direction, right? T will never be on the left side of a. It'll always be on the right. So it'll be approaching a from right. That's the definition. Again, remember, you have to use this definition to solve an improper integral of this type. If you don't, it will look very innocent, and if you try to just directly use the fundamental theorem, you are not going to get full credit. All right, so another type can be same exact thing, but the problem will be at the point b. So the function is continuous everywhere except at b, where it has an infinite discontinuity. All right, so how do I evaluate that? Again, what we do is very simple. You evaluate from a to some t. And then take the limit as t is approaching to b in this case. Now, where is t going to be? On the left side of b, right? So t will be approaching to b from the left. So only one-sided limit again. Remember, this is a situation where f is continuous inside A to B and not continuous at B. Okay, and then there's a third type. Well, as you can see, these are the situations where the function is being not continuous at the endpoints. What if the function is not continuous inside the interval, right? Inside the interval. What do we do then? Okay, so let me pause the video a little bit and then I'll erase the board and come back and finish this.